Hello. So today we're going to be optimizing this game right here. It's an indie game called Far Far West, and we have the engine source available. So this is running in Unreal Engine 5.7 on actually an RTX 3060. So it's not running on any kind of beefy hardware, and so we'll have a really good idea of things that need some optimization. We can actually apply some optimizations today, and so by the end of this video, we'll have made some improvements to the game that can actually be committed or at least discussed with the team. Like, I'm not a part of the development team, I'm just helping them out with some optimizations. And so in this video, I'll focus on the process of making an Unreal Insights trace, analyzing the profile data, and then figuring out what that data actually means. And we'll reason about maybe some improvements, we'll apply them and we'll test them. So we actually go through the whole process. Now, for each of these things that I'll cover and a lot more, I have more information in the optimization courses, a lot more other lessons as well with really in-depth information about every subject. And also we have more case study lessons there, both about this game, but also from other games such as the Forever Winter or the Liar Starter game. We're running this on the 3060 NVIDIA GPU. So I am not going to tune this for epic scalability. That would be rather silly. I think we should place it as more of a mid-spec GPU. And also for optimization, of course, we're not going to do anything with DLSS, no upscaling. It's just going to run natively at 1440p, and we'll see how that performs and see where we can make improvements. Now, if I start to play here, a lot of combat will happen. So instead, I think I'm just going to run this in the game preview mode with by pressing G. And I'm going to just reason about some of the performance and some of the improvements that we can make. So if I just do like stats unit graph at the very least, and we will also be using Unreal Insights. So stat unit graph, I also want to type out stat FPS, so we see the frame rate. So we have, we're running this at 50 frames per second or 20 milliseconds per frame. I'll just open up the session browser that I have on the second monitor, and then also, we don't really need any special channels here. And yes, I am going to run this within the editor. So we have to ignore certain stats. Like anything like Slate UI is going to be utterly useless as a stat. We also can't really find the true bottleneck necessarily because editor timings would mess things up. Like especially like blueprints would be a lot slower in editor versus a cooked build. But for the purposes of this video and for our GPU stats, we'll still have a really good idea of where our performance is. And that way I can also immediately show you what's going on. But generally speaking, when you're investigating and profiling, you'll make a cooked build of your game and actually have something that you can ideally run through consistently. But that's a little bit out of the scope, and that would make things a lot harder for this video. And we'll still have good stats for the GPU by doing it this way. Okay, so I'm just gonna run. And actually, I will make it viewport so that we have like a consistent sizing here. I'm actually just going to fly through it. I don't want to actually have any kind of combat. That would, of course, be not very deterministic because the combat will be different all the time. And that would be very interesting to profile as well. And also, of course, we can make a spline. We can do this all automated. There's all of these things that we could do here, but I'm really just going to focus on doing a couple of very simple optimizations, but I'm just going to focus on a really simple fly through rather than setting up any kind of complex automated system. I think that's probably a pretty good look because I think there's going to be some performance issues in this village. We had a lot of foliage at the start as well, so I think we can just stop it right here. And I'll just open that session that we just ran, and we'll see what we can find. Now, ideally, if you're running this on a spline, so you have your camera just going through on a spline through your cook build, then you also want to run things like the trace.screenshot command so that you know where on the spline things were happening, because you'll see the screenshot output right here in the timeline, which is going to be super useful. And so if we actually look at this, for example, like here we can see a big spike in the game time. However, if we look into this, I can actually see hit proxy readback. So this is just something that is editor specific, right? Because when you click something in the editor, it tries to figure out what is underneath the cursor, and it will do some hit selection. So this is one of those reasons why running this in the editor can be problematic, because you see this whole hitch, and you're thinking, oh, that's going to be a problem. It's just an editor specific thing. So I'm going to completely ignore that, even though that's pretty slow. It's not really the issue that we're going to be interested in today, because that's not ours to fix. So I'm going to just zoom in on a random frame. One thing that immediately pops up is that the nanite vis buffer is 6 milliseconds. Now, the thing is, you don't always know if something is too expensive or not, especially if you haven't seen it all that much. So 6 milliseconds, you might, if you see this for the first time, you might not know, like, is it too much? Well, I mean, 6 is pretty enormous. So you might be able to understand it. But what if it was 4 milliseconds? Is that too high? You don't always know. And so the thing we have to really figure out is, what is the vis buffer really doing and what affects its performance? Now, I know that 6 is way too much. So immediately we should look at the NanaVis buffer. And actually, one thing we could do is, if we just select it here, the NanaVis buffer, and then in the timers view, if we just double click it, we'll also be able to see this main graph. And if you hold shift and do the scroll wheel, we can actually get a more useful graph here. And we'll see along the time where most of the time it's actually pretty high. It can even reach 7 milliseconds. And at the lows, it's 3.4. One thing I really hope Unreal Insights gets in the future is that we just see, like, automatically some visual input of, like, where were we in the map. We can add bookmarks, we can add those screenshots manually. Now I haven't really done anything, so I would have to think, where in the map could we be, which is not ideal, of course. But we see that it sort of flows between like mega high, like really crazy high numbers, and 3 points or like 2.9 or so. I think it's still too high, but it's significantly better, right? And we can also argue then 7 is just too much. So that is one thing we would definitely have to look at. Now, besides that, I think I want to have a few other things to discuss before we really dive into figuring out some optimizations to apply. Because the other thing that we have with more recent versions of the engine is that now we have the graphics track on the left here. You see the graphics track and the compute track. And the really cool thing about it is that we can finally get a better understanding of whether or not something is running using async compute. And so it tries to fill gaps, and it tries to use all the available resources for the GPU when other passes might not fully utilize them. And so what you might think is that if you see the GPU compute, or previously if you were using like a stat GPU or a profile GPU, whatever, you might see something like FX system pre-render or anything else, and you see, okay, that's 7.6 milliseconds. Why is it so expensive? That's crazy. However, it's actually mostly just doing a GPU wait. It's not really spending much of that time actually doing anything. And so most of it is just waiting for some other dependency to be ready somewhere else in the pipeline before it can actually start doing its stuff. So definitely have a look at the GPU waits to be able to know whether or not it's just like a dependency issue or like a scheduling issue, or rather that there's just not much to do on the GPU on a compute side at that point. Don't worry if you see that, and don't start to stress like, are my Niagara systems like messing up the game for some reason, and I can't understand why. It might just be waiting. Wanted to make sure that was mentioned as well. So we have, besides the vis buffer, and if you're not familiar with vis buffer, that is really just trying to figure out what meshes end up on screen, but also which materials need to be rendered later on. So later on, we have the Nana base pass, and that is sort of using that result of the vis buffer. So that's using, so the vis buffer would also be doing like occlusion checks, figuring out which pixel is going to render which material ID later in the frame. And so that would then happen during the base pass. So the base pass would, for example, be a lot affected by the rendering resolution, but also by material complexity. And the vis buffer, as we'll see today, also going to really be affected by the material settings that we have. So this is really a messed up material settings issue that we can really improve on quite significantly with a few improvements. Some are going to be more work because it's foliage related. We're using foliage with masked materials, and that's really blowing up the cost. And then what other thing I see here is, for example, decals. Well, there's a whole bunch of other stuff, right? But I just want to focus on a few things that I think are interesting to look at today. And so decals here during the composition before pre-pass, and it's taking up 0.3 milliseconds. And there's only 2 relevant decals. So to me, that's interesting because 36 of them were available, but 2 were only rendered. And so why is it taking up 0.3 milliseconds? It sounds excessive to me. So we have to look into why that might be happening. And also maybe we can, once again, double click this to figure out how this scales over time. So now holding down shift again, you can once again reframe this, how that is growing or shrinking over time. And so at some point, actually, we see that so the 0 points, well, actually the lowest here is 65 microseconds, but then the largest one is like 1.3 milliseconds. That sounds very excessive. So here we see 1.3 milliseconds, 8 relevant decals. I don't think the decals are going to be meaningful enough to be worth 1.3 milliseconds, right? That's another thing. Like, how do you really think about your budget in a frame? What is too much? A lot of it is relative. You have to think, okay, we have 16 milliseconds. How important is this to the contribution of the scene, and how fast could we possibly make this? How fast you could possibly make it is often really difficult, especially if you're not a graphics programmer. You can't necessarily dig into the engine code to improve it, so you just have to maybe change your assets to be more efficient, or your content, or tone down certain console variables to make it more efficient in that regard. Oh, actually, one thing is interesting. I'm actually looking at a different thing here. I'm looking now at decals under the light composition tasks pre-lighting. However, previously we were looking at composition before base pass. They just happen to have the same GPU performance marker. So both are called decals, and so they just show up individually. However, that actually shows an interesting thing, because here it's also 0.7 milliseconds. And later in the frame, we pay another cost for those 8 decals during light composition tasks pre-lighting. And we can see here it's deferred decals emissive. And I really hope you can read this text. Like, please watch this on the highest resolution you can. Because this text is really small and window scaling is not helping me. I can't get this to be any larger. At most, I can do this actually. I can kind of zoom in a little bit. So probably I should be doing that whenever possible, but you can still see it's not upscaling that well. So we have deferred decals emissive. Again, it's only 8 relevant decals, so 8 draw calls here. The interesting bit is this is only doing emissive, and yet it's so expensive. Like, what's going on? So that would be certainly a thing we should improve on. I have a more in-depth lesson in the optimization course as well about decals, but regardless, we'll try to optimize this in today's video as well by doing a few simple things. One other thing that's interesting, because they use the same stat, we actually see it's costing, if it can select it here, 0.7 and here 1.3 milliseconds. And that is when we double click the decals, it will actually show it as a per call cost. So if you have a lot of calls to the same stat in a frame, they're individually displayed here. But one thing we can do as well is, if I were to just, let me see, plot timer, right click on the decals, right, plot timer, and remove instance series from track. And what we can do is plot timer and add the game frame stat series to graph track. Now what we see is something a little bit different, because now what it should show us is the overall cost. So it combines the multiple stats that use the same name, and it combines them into a single number. So sometimes that is more useful. If you have a lot of costs, which might especially happen in your game code, it doesn't happen as much with the GPU, because they're usually distinct stats, of which you only have like one or very few. But if you look at your game code, you might have a whole bunch that are using the same name. Now we don't have much happening because we weren't doing any gameplay, so we currently don't have a good example here. But then it would be more useful to actually sum them all together and show them in your main graph as a sum of all the individual calls, as a more useful metric rather than all the individual calls. And so then if we zoom out, we can see that here we really have really awful peaks of like more than 2 milliseconds just to render a few decals. So certainly that's broken, right? We need to at least improve on that and see where in the content that's really busted. Funny enough, actually, what we see is when the decal cost goes up, you can see that the nanite vis buffer cost goes down. Now that's just a little bit of a coincidence based on the content, because I still have the thing open here. I know that actually it's happening while we fly through this village. And so while we fly through the village, we don't have much foliage rendered. And so as it just happens, they are correlated now, because while we're in this hard surface environment with less foliage, we reduce that nanite rendering cost, but we increase a lot of the deferred decal cost, because there's a lot of these decals actually that are shown on these bird buildings right here. Now, there's a lot more to talk about, but I think we should just first go and investigate those issues, right? Because we're already quite a while into this video and we haven't really touched anything yet. Now, what you would do is, assuming you would have a spline or something consistent, which I don't have for this video, but I just made my own sort of fake spline movement, you would kind of know where in the profile you have your, where in the map you are, or you add some like trace.bookmark, give it a name, where you are in the scene, or you have trace.screenshot, and then you have actually like a visual representation of those things. But we were sort of flying from roughly here all the way to the other zone. So I'm going to look at two things. So we'll focus on the nanite, and we'll focus on those decals, and then we'll have other topics to discuss in later videos as well, because we could talk about this for, well, hours. But let's go ahead and actually make some improvements. I'm just going to use stats GPU because I want to verify that this is actually also happening right here. So F11 to go full screen. Maybe let's use game viewport to have all those editor things hidden. And we can see that the nanite vis buffer here is 7. So it's 7.3 or so milliseconds, which is kind of ridiculous. I mean, there's other things that are also very expensive, but that's really the outstanding thing. That's absolutely way beyond any budget. So we can just quickly inspect why that might be happening, because usually what happens with nanite, and especially when we have a lot of foliage, depending on how you've authored your foliage, right? These days they have, or at least they have experimental feature for the voxelized nanites, but we can't just within a day change all our content. I mean, maybe they'll be able to change the content. I don't know if they have the means to do that right now, but also it's an experimental feature. So I wouldn't immediately want to push them into an experimental feature when they're soon releasing into early access, right? You have to be a bit risk averse. So we'll just see the best job we can do with the current content and make these smallest changes, hopefully get still a lot of performance back. So let me just first go into the nanite visualizations and just, well, the first thing you would check is like evaluate WPO. Now, the funny thing is I'm also going to do stats none because I don't want to show any stats for now. The thing here is that when it's green, it's evaluating WPO. So that's actually the bad thing, right? We don't want to have a lot of stuff that is evaluating WPO. At least one thing they've done is that you can see as it goes further away, they have this thing where they disable WPO. So they're no longer animating those foliage. Now, WPO used to be a really beautiful, a little bit of an animation trick, and it was quite efficient. With nanite, it's really quite bad. So we have to try and reduce this or turn this off as soon as possible without the player noticing that the things are no longer animating. So I think even those things already in the distance, right? Actually, I'm holding down right mouse button and clicking C so I can zoom in. The foliage in the back there, I think we can already disable those as well. So we can maybe tune this distance to be a little bit closer. And then we should add a blend. Like by default, it's just an on-off kind of thing. So if you're not animating your foliage and at some distance you enable the animation, it might just pop into the animation. And so it might be a little bit egregious. It doesn't blend very well. So we have some options available, custom options available to blend that in. But there's actually a thing that is worse that's happening right now, and that is not to evaluate WPO, even though that is pretty bad. We also have pixel programmable as a thing to look at. And pixel programmable can be a number of things. It is usually whether or not your material is using masked material or if it's just opaque. Besides that, it also is things like pixel depth offset, which is another thing that is truly horrible performance for nanite. And so what we can see here is that a lot of that stuff here, actually, all the foliage, all of the trees as well, is using the pixel programmable. So that is really using the slow path. And what we have as well with this visualization is another command, which is a little bit hidden, but I literally just discovered this by going through the engine source. And this happens a lot. When you just search, for example, if we just remove this, if you search for pixel programmable, and you can even have space in between pixel and programmable in case there's a word in between. It will just be able to search for whatever you might be looking for. So we don't even have to know that this r.nanite.visualize.pixel programmable viz mode. We just have to remember it was something pixel programmable, and you just search for that and we'll just find it, right? So here we see a viz mode. Another thing I like here in the editor, of course, you can always search the engine source, but in editor, we can also see what these modes mean. So we have 0 is show masked pixel depth offset and dynamic displacement materials. Now, I don't think they use dynamic displacement, but I will use both mask materials and pixel depth offset. So I want to first show this in mode 1. Nothing changes. So yeah, they're all using masked as I remembered, but we also want to check 2. And well, actually, they're not all using that, but a lot of them are. I think somewhere here, something was changing. So if I just go back to 1, yeah, that little thing right there is not using PDO, but all of the foliage is. So I think that is really where a lot of our performance issues is going to exist. So then let's find out what material is this using? And I'm just going to go ahead and enter the foliage mode and click select and hope that this is actually foliage. And so either this is going to be grass or it's going to be foliage. We'll find out soon enough. I think we should first maybe go back to lit mode and with select. Now this guy, this guy I can select. So this is foliage. And that's also actually one of the meshes I would like to look into later as well. But I think maybe this is not selecting, so it's not actually foliage. It is grass. So that means we'll have to deal with these guys later because all the foliage is a problem. It's not just this dense piece of foliage. Like literally every piece of foliage is kind of an issue because these guys are also pixel programmable, and that doesn't disable at any distance. So they all have the cost. I mean, here, over here, they at some point disappear, but that's just distance calling. That's not actually leaving the pixel programmable. It just no longer renders anything, which is of course the cheapest way to do it, but it's also not the best. So let me go back to the lit mode. Here we have this plant right here. Now, I wish I knew whether or not these tools are better. I think it's just this cat tail. Yeah, that seems like the mesh. SM cattail. Let me open up the swamp foliage, and that derives from MM foliage, the master material foliage, and it just has this pixel depth offset linked up to some kind of dither temporal AA. Now I'm very curious what that's doing. The thing is, like, whatever it is trying to do, and it's probably trying to blend, like pushing certain pixels of the mesh a little bit back into the depth buffer so that it can maybe blend a little bit better with the environment or something like this. However, what I would like to check out is when we are like here, and I'm just going to get out of the foliage mode. I'm going to use stat GPU once more. Now we have a vis buffer of 5.5. What if I just get rid of this thing? So alt click to get rid of that and apply the material. I had that compile for a sec, and now I'll come back here. We're still in the same area, and we'll let it settle for a second. Now we're on 3.7 milliseconds. So we gained a pretty significant chunk of performance, but I don't know if there's any like meaningful difference there. I'm just gonna put this on a different screen, just off the view, and actually see if we can get any sensible visual difference. Now, the thing is, again, it might just be blending it a little bit differently, but the cost difference in milliseconds is so absurdly significant. I don't think we can really argue that we should keep that. I see some, oh, that was just a temporary pop of the material. So I was just compiling. So that's why it looked a little bit different. Okay, so I want to keep this disabled, like pixel depth offset. That's going to go. We get rid of this one here. And this was a real material. I didn't place this one just for show, right? This was actually, this existed here. And really what I could figure out was maybe it was trying to blend like better with the ground or with other like nearby foliage surfaces or something. But the cost is just way too significant for this, especially with nanite. Like nanite really gets murdered on anything that's not fixed function, really. Where fixed function is anything that's not dynamic, right? It's just as soon as you use world position offset to animate, it's no longer fixed function. Or if you use pixel depth offset, anything that becomes per pixel, becomes extremely slow. So now let me check out the nanite visualization again, pixel programmable. Now this is still, the overall pixel programmable is still really slow. However, if I search for pixel programmable again, viz mode, let me check 2. Okay, that's cool. See, now we can at least see that all the PDO is gone. So we have at least solved that part of the performance issue. And we have already seen in the stat GPU that that's faster. But now viz mode 1, the mask material is still happening. Now, some time ago, also Epic suggested a workflow where if you are stuck with mask materials, which we are, because if we just look at the foliage, we have just these opacity masks. And this worked fine without nanite, right? And also this game supports non-nanite as well. So for DirectX 11, for example, with integrated GPUs, where they are also going to support things like DirectX 11. So then you have a non-nanite workflow. And so then masked foliage again works. However, for nanite, it just really doesn't. So I'm going to just try to make this perform as best as possible with the current constraints, and maybe in the future nanite voxelization does become available, and then all of these meshes will certainly become more performant. However, then we still need to change all the content to not be mask materials, but use actual geometry to represent the mesh, right? And the thing is that in certain cases, that is already available. However, certain things like this plant right here is really heavily dependent on a mask material. However, if I look at this guy right here, the cattail that I just opened up, if I just look at this material right here, the MI swamp foliage, I'm just going to open that up, and I'm going to override the material properties to be opaque. So now we no longer have any opacity. And then we can actually see that it is already kind of matching the outline. If I were to just check out like wireframe or maybe lit wireframe, we can see that they have already modeled out in this particular case pretty closely, like not 100% accurate. We can see a little bit of artifacts here where white is coming through. However, it is pretty accurately representing the material. So two things we could really do here. I think either this material or this texture should be fixed, because by opening up this texture right here and just unclicking alpha, we can see they have this white background. They might as well make this background like maybe green, or maybe they should fix the texture to be slightly larger to go a little bit further so that it's not leaking. But this we could use, right? We could maybe even force this this material to be now opaque, because if we're looking in game, now we no longer have that mask cost. So this is actually going to be cheaper now to render, because we no longer have, well, I mean, we still have world position offset, but we no longer have the mask material, which on top of world position offset is really slow. So this one would be better now, with a slight adjustment by the team to maybe fix up the material. Now, others might be trickier because they are not properly modeled to match the texture yet. And Epic has suggested a workflow where what you could do is at a distance, you have a pixel programmable disable distance or something named similarly to that, where beyond a certain distance, you just disable that whole feature. And what ends up happening is that this material becomes opaque. What I've just done manually, right? I've just manually make this opaque. Then the engine would do that, and sort of whole masking just sort of disappears. However, for that to work, you need to have a good cutout on the mesh, like a good silhouette. Because if we were to just do that on something else, actually we can't really do that on the grass, because as you'll see, even though it was suggested as a workflow, it's not really supported within the engine. I can't really figure out as of 5.7 even realistically how to do this cleanly, because I mean, maybe I'm blind, but I don't see any option in our grass or in our foliage tools. The only thing that does work is if we go ahead and, well, actually select, well, here we already have it selected, Instance Foliage Actor. So if we just have one selected, like the Foliage Instance Mesh Actor, here I do believe we have nanite pixel programmable distance. This is where we can actually tell the engine to stop using that mode and return to a fixed raster mode beyond a certain distance, much like what is available with world position offset. However, that's only available on this actor that get automatically placed because of the foliage tools. So I'm not even sure if at any point this might reset, but also we can't like nicely configure this in the foliage settings or in the grass settings or anything like that. So we would have to just go ahead and figure out where or which one of these meshes is the one we're currently interested in. And I just remember that that's actually not foliage, right? This is grass. So I keep confusing those systems. So for that to work, we go into the content browser. Landscape grass type is what I'm going to be looking for. So what do we have here? Unfortunately, we don't have good thumbnails here. It would be nice to see the mesh as a thumbnail. So I'll just have to go by name. And it's probably cornfield, where there's going to be a bunch of grass varieties. And I see corn C. This is probably at least one of them. Now, if you look at corn branch here, if I set this one to opaque, then we actually will have a pretty reasonable cutout. So this is another one where we could probably get away with it. If you look at this from a distance, and if the texture of the corn, if this alpha was not white, but was more closely resembling the general color of everything here, then we could probably get away with this being rendered as opaque from a distance. So when you get up close, of course, you would toggle back over to the masked material. And then from a distance, you would go to the opaque version. So that's the pixel programmable distance toggle, really. And here you can see it, right? Here we can see what it looks like. Of course, the texture is not good, so this looks pretty bad. But that is a possibility. However, I don't see that option also on the grass. Like if we just look at the landscape grass type, we have stuff for disabling the world position offset. Here, the instance world position offset disable distance. If you have a custom engine version, you might be able to just do that. Add a new float value either in the grass or in the foliage asset types, right? Either in the foliage selection, right? This is like these stuff will also be like SM Cactus B foliage type. This could also just get a pixel programmable distance added in. Now let's have a look what that could potentially be in terms of cost. Now this is of course also doing it up front, but I just want to have a bit of a ballpark number of what is happening right now. So now I see a 2.5 or 2.6 or so nanite vis buffer. And then if I were to just put this on another screen, like this, and I just disable the blend mode to be, once again, the mask material, then I see 3.6. So it's 1 millisecond difference in order to, between using a mask material and an opaque material for this cornfield. So that's really something we should look into further because of, well, even though unfortunately the grass is not fully supporting that pixel programmable distance, wherever we can, so let me just get rid of stat GPU again. Whenever we can, we should convert any of those meshes to have either a perfectly aligned cutout and that we can just use an opaque mesh in the first place, which would be ideal. Or when that's not available, try to make it a good, a really tightly packed silhouette by adding a little bit more triangles to make that silhouette work. But at least at a distance, we can then disable it. And actually, let me show you what that looked like, even though it might not look super good. We have here a birch tree. Here, I can actually now search for pixel programmable. It's just a regular mesh, it's not foliage or grass whatsoever, but it has that same disable distance available. So let me see, let me at 2,000 units or so, which is pretty close, as you can see. Now it's disabling, see? So as soon as you go from a further distance, it actually just toggles over. So that would now with this mesh just not look good at all because the difference is just way too stark. So even like something that's much further, it's just not going to work with that mesh because it's just, it doesn't have a good cutout. Maybe with a good cutout, you might be able to do it. And I think there's some other material tricks that we can do to blend that back in. That would be something that I would like to investigate. But the first step is find a good silhouette, especially with things that are more lower to the ground, because a tree has such a strong, like standout look that this is not going to look very good. And the popping is like significant. So this is probably an asset which is very problematic. Maybe we can't use the pixel programmable disabling distance on that. So then let's do one more thing with foliage before we move on to those decals that we were also seeing. Because we're running this on a lower end GPU, I also want to make sure that everything is set up properly for scalability. So let me go ahead and see, well, what like any kind of foliage that has a lot of instances. So this has almost 44K instances. That's probably one we should check out. So let me go ahead, right click, select all instances, and there we go. There's a lot of instances, right? And let me check if there is actually density scaling enabled on this. There's not. That's great because that's easy because it wasn't enabled yet. So we can now set enable density scaling on this. Just going all the way down to the bottom of that particular foliage type. Now we have the option to actually, when foliage quality level gets reduced, we can just spawn or show fewer of these, well, not really critical, I would say, foliage meshes. Now, this is something you would probably not want to do with things that are like trees or giant rocks that might also be foliage, because then it's going to affect the collision of both the player or of projectiles and those kind of things. You don't really want to have anything that has like a gameplay influence, but this bush would not really have any kind of collision in the first place. We can also see that there is no collision. And so then it would be safe to actually enable density scaling. And then we can use things like sg.foliage quality, which at the moment is on 2. If I set this to like 1, we can see the two things that it's actually changing here that it's affecting. So we have foliage.density scale, and we have grass.density scale. Again, you see that there's two different systems. Grass and foliage are two different systems. And because I previously was messing with the grass.density scale, it is actually no longer being able to set by that scalability group. So SG is scalability group, that foliage quality. So if we just do grass.density to scale, let's set it to something like 0.4. There you can see that the grass type here gets really significantly reduced. So this could be another way, or would be another way, to scale down on lower end GPUs. And you of course have to tweak those values to be meaningful, that they of course scale down enough to have a performance impact, but not too far that certainly your whole map is looking super barren. You should definitely have this on things that are not meaningful or just add a sort of lushness to the levels. But of course, if you're running on a low end GPU, you would prefer like a consistently high frame rate rather than like super lush levels that run at 20 frames per second. So that's really where you would want to make that trade-off. Like how far can you scale down without really making the levels look super awful? Anyway, that was the grass, the density scale. I was interested in the foliage. So that would look like this. So we have these bushes that are going to be scaling down. Foliage, the density scale. Now, if I set it to 0.1, which is pretty low, it's probably too low. Like 0.4 is more the current scale that we're using. We still see that we have like a decent chunk of those bushes, but not nearly as many as when we're 0.8. So this could certainly help us in our GPU performance without again affecting the gameplay, because these are like low to the ground. They're not even really blocking visibility or anything. They have no collision whatsoever. In this view, we would have to do this with a couple others as well to really get like a full performance difference. But what we could see is if we just go back to Nanite visualization, both the evaluate WPO, if we set that to like 0.4, we can see that a lot more is red, which is red is good in this case. And then with the Nanite visualization pixel programmable, the other thing as well is that now that would also be reduced. And now, of course, we have to set that on these, especially like I think these are pretty dense. So let me actually try to figure this one out too, like to see if it's grass. It might be grass. Maybe it's something else. Let me just first go into foliage mode, select. Oh, it is actually foliage. It's probably this little dead bush. Yeah, there we go. That's the one. Okay, so this also should absolutely have things like density scaling. Now, I'm not going to make the same mistake to try and enable it here. I'm just going to look for the name right here, the foliage type, and search for that instead. Little dead bush foliage type, and I will just enable density scaling. Now you might also want to do distance scaling. That's also a good idea, but I'm just going to focus on only the one with the density at the moment. So let me get out of the foliage mode again, and let me do a quick comparison. So if we have this view right here, where we have the stats GPU, and then the foliage density scale would be either the 0.8, which we're now at 2.8 or so milliseconds for just the vis buffer. And other things are also going to be affected, right? It's not just the vis buffer, but that's really what we're focusing on at the moment. And then with just a little bit toning down, it's not even super aggressive. And it's only on 2 types at the moment. We are at 2.4. So we do get 0.4, 0.5, I see now or so milliseconds of frame time just by slightly toning down the grass on 2 of those types. Now, there's a lot more that we need to do there, and especially because they're masked, this is just a performance issue. But we can't really solve the whole thing in like 45 minutes or so. But at least we've now investigated this. We've applied already a few fixes, right? This is already down quite a bit. And now just more broadly, we should be applying all the density scaling, figure out like good numbers for that, for both the grass and the foliage, and then see which other meshes, because we already changed this with the mesh right here at the water. These are now also already being able to be just rendered as opaque at any distance if we just fix up that texture a little bit. I think we can spend a lot more time on this to really get that to perform properly, and we really should. A lot of that is going to be repetitive work. But I think for now, what I want to show off is the decals, because we could also see that that was pretty intense. And then we have just so many other things that we could really talk about within this game that could be further optimized. Well, this was more of a global look at the stats and then just figuring out what was being shown. But of course, Nanite was taking up the bulk of that time. So I just want to make sure that we also cover the decals for a second, see what's going on there. And then maybe later we have additional parts to this lesson, because otherwise we'll have like a 4-hour lesson. So what happened actually, now that we go and look at decals, is at some point I was flying through this with my fake little spline, just going through the level. And at that point, we entered this map and we got a little bit of an increase, or like, well, I would say not even a little bit, a spike in the cost of the decals. If we go back to the Unreal Insights, which we haven't looked at for a while, the spike was somewhere around here, right? And that was roughly when we're entering that little town. That's also when the vis buffer went down, because we were no longer rendering that much foliage. So let me have a look at really what's going on there. Probably first I press G to exit the game mode. Then one thing I would like to just do is maybe search for decal, and I'm just going to select these all, because then we can see the outlines here. So here you can see why probably this is happening, because there's in a few places, also here as well, actually. It's interesting because there's these hubs of large decals, which would explain really the cost. And I have this lesson on this as well, right, to go into more detail, but I would like to try and improve on this a little bit here today. And so the decals cost will scale in a few ways. So the first thing is that while we are here, we have the composition before base pass, which just renders the decals, but then we have the other pass later on, which is the emissive. So as soon as they have the emissive channel linked up, they will also have a second pass where they're adding more cost. Now the problem there is So there's these little glowing dots on the burning effect that is causing that extra cost because it just renders it a second time as an emissive. And then on top of that, the screen size also largely affects the overall cost because it gets projected onto the screen. So it's a little bit like lights. Also, if you have really large lights, their projection cost is going to be more expensive depending on how much space they took up on the screen. And so what we should do is try to make these as small as possible. And also, even if they're stick through the floor, that's still going to incur the cost because they're at least, well, they are still really large. And then a secondary problem to that is when they're really large, it takes a longer time for them to properly fade out depending on your settings. Because if we just go and have this decal selected, we have a fade screen size. What would happen is that, well, depending on how it's set up, now we are fading in and out, right? So as we approach, or as we zoom in this case, the decal starts to be rendered. Now, the cost is incurred as soon as it starts to render. So maybe here it's not rendered now in this building right there. But as soon as you, even if it's 0.1 opacity on the blend, of course, now it just takes the full cost of the decal. So I want this to be able to fade out as soon as possible without the player really noticing. So this actually could possibly be noticed because as you're approaching, it does sort of blend in quite a dark decal. So we could maybe tweak this a little bit better. But for that first, I would want it to be a smaller shape, right? Because honestly, we could just scale this down so that it just about clips the mesh right there and just make this go as small as possible without really messing up the look in any way. So I have to make, this is a really annoying thing because you have to like manually go in between all of them. And so we can't always make them smaller. It might actually be worthwhile to maybe add even 2 of these possibly. This is really a trade-off where you can make them like much smaller, but that really depends on the decal. And so now it is at least smaller, but that also what would happen is now it will fade out even sooner. And so I think we should maybe set this to be, maybe we want to have it visible from this distance. Let me check this out, 0.1, now it's visible. And then if we zoom out more, I think probably 0.15. Let me go in between the 2 values. Okay. So now it sort of blends in at this point. And then the second thing what we have available to us is not set up by default, I believe, but we do have and again, we could just search for decal. And if we don't remember the full name, it's something like fade screen size multiplier. That's currently set to 1 and do it something like, well, at maybe a low scalability, we might be at, I don't know, 0.4 or something. Because that way, it does blend in a lot later. And maybe you would think like, well, this is too much, right? This is maybe way too late. So you'd have to figure out like some good numbers for yourself that match with this fade screen size. Now, what we should do here is to make this work, to make this actually viable, is we should also make this, like this one is now going way too soon, right? So probably the 0.4 is too aggressive. So maybe 0.6, 0.8 and 1 or something would be a good balanced approach. Like 0.6 would be a bit more reasonable. But also you can see that this one is also enormous, right? It's really, really large. So this is just also wasting a lot of, potential performance. So I'm going to try and make this like a lot smaller by at least, and trying to keep the overall look intact. Like that's not super easy. And you can see at the edges, at some point, it becomes a bit of a clipping issue where I have to make sure that I don't really mess that up, or we should make some changes to the material and how that blends with the environment so that we can have a much tighter fit on these volumes. Because we could see that 2 milliseconds for just a few decals is just way too much, right? We should make this like significantly tighter. So we should probably have a look at how we can tune this. Now, also, again, the 0.2 is it's fading out too soon. So maybe 0.125. I'm just tweaking them at the bottom right here. So if we were to do this for all of them, we would at least be able to cut this down a little bit. Now, the other thing is maybe we could figure out a way to not render into emissive from a certain distance, or maybe we can not render into emissive on low-end machines. Although this does add a nice effect, but it does also double the cost of our decals, right? So we have to figure out what else we could tone down to make this work. But really, the first thing to do is to just make sure that we don't have that many crazy large decals. And also you could argue that maybe some of these decals we could actually just disable entirely on lower end. Now, I'm not sure if I can find a good example for that here because these are all probably important, or at least somewhat visually important. But maybe if we just have a few that are overlapping a lot and that are maybe more subtle, we could consider getting rid of them. So let me just grab one and to make a point, right? Okay, this is another huge one. For this, I might just want to use R.detail mode and said, well, if you are on like high or you're an epic, only then do I want you to be rendered. So now currently we are just culling this thing entirely, which let me see if I can actually see the difference here in performance right now. I would have to reselect this guy. I'm going to just lock this so that I can just disable the selection, but keep the properties. Now we unfortunately don't see the proper name of decals, but we do see composition before pre-pass, and we see composition pre-lighting. Now, pre-lighting is also going to be affected by screen space AO. Actually, also composition before pre-pass might be affected by screen space AO. Currently, it's not. Currently, in our case, the screen space ambient occlusion is in pre-lighting. So we have 0.8 and we have 0.3. And now I can see that it is now 0.9 and 0.36. So it does actually add some cost here. And actually now we can see almost 1 millisecond on the pre-lighting. And we can also see that it is 0.4 on the composition pre-pass. And then of course, let's one more time just toggle that one off entirely because it does add some detail, but the player is probably not going to notice if it's gone. And we do get a little bit of performance back. And this is something you would do on like the least significant decals, right? You don't do this on all the things that are really telling a story with the game or with the environment. Like that would be a waste. And we can once again see it dropping down. So this is, it's a meaningful impact for like a single decal that we turn off. And realistically, what you would do is you would try to figure out which of these decals are the worst offenders without contributing the most, like which contribute least. And also, first of all, you would just make them all smaller, try to make them tight of a fit as possible. And then we would see like maybe we should still call them on lower scalability modes using R.detail mode. Or actually, it is called detail mode, and the option actually that is being controlled is R.detail mode, which will be a part of your scalability settings. And then also here behind my screen right there, you could see the options on how they're used. And also one thing you can see is that when you're getting a little further away, like the emissive detailing is really just starting to break down. It's like barely contributing like maybe 10 pixels to the screen, and yet it adds a meaningful cost. So maybe you can figure out a way to call that. That would be an interesting one to consider as well if we wanted to dive into this more deeply. But we can already get a lot of performance by just doing the really simple content changes. Now, finally, I will just open up the decal material as well, because I want to make sure that that this material, if I'm just going to just drag it into the map, I want to just have a quick look at this. So this is what it would look like normally. And so it does use at least all of its volume, because that's another thing you would often see is that you would maybe have this decal and it only ends up using like this much of the texture space. And then this is all just dead, like opacity 0. And so you have to have this really large volume, and yet it will never contribute anything to the scene in that huge space. You want to make sure that wherever possible that you have like a really tightly fitting texture to the edges so that you can, be as efficient as possible with your volumes. Now, let me check out actually, because this is also interesting. Like I was saying, I don't know all the answers beforehand. We're just discovering as we go. Okay, so what we just have happen here is that basically, I think if we just scale this guy up, eventually we get this fall off, right? So here we just have, it's just all parameters in the material. So as we get beyond a certain size, then of course it starts to look good. Maybe I think what we can do here is change the material, the underlying material, because it has these values that we can tweak. So it does also have a radius. So if I were to change this radius, see there we can sort of tweak it. However, it's using a single value for all of those. So if we now change it here, all of these get affected. And this mostly works well if we have like a square decal. So what we can probably do is try to figure or try to tweak this radius and also the hardness, because if we change the hardness, it also changes the material fall off, and maybe tweak this to be as tight of a fit as possible with the decal. So realistically, we should change the material here so that it scales better with the size of the decal. so that we can have a more tightly packed decal material, so that it always has a nice fade off towards the edges. Because what was happening prior was that at some point here we see this cutoff, right? This is just a material fading issue, where now if I were to just, once again, I have to keep everything on one screen. If I now change the radius, we can see that now we have a good fade off, but now we don't. So we need to have a better way to manage this on a per decal volume basis. Let me go ahead and see if I can quickly do this, and otherwise I'll just mess around with this a little bit offline and then make sure that that is properly applied. So do we see anything? We can also just search. Oh, I already found it. Radius right there. Maybe I should add something like object scale to this. But this also states that it's not compatible with the pixel shader. So maybe I can use object bounce. Maybe I can just use extends. This is also not available. That is unfortunate. So it seems like a lot of these are not available in this particular domain, which is a little bit unfortunate. So that means we don't have the usual things available, which I would usually try to just mess with. But on a decal, that's not available. So that's a little bit unfortunate. The other thing that's also not available is the components material parameters, which we would have available, for example, on our meshes, but it's again not available here. So there's really not a lot with these decals, unfortunately. So what I'll do for the decals is then figure out a way to make that work better with the size of the decal, and so that they can all have as tight of a fit as possible, so that they are not like all of these huge volumes, and rather are like tightly packed, so that they take up less screen space and therefore less cost. Now, we could either end this here, but I also saw earlier, I saw this distance field shadowing that was enabled. And you can see that here, if we go back to the Unreal Insights, one of the things that I saw, it was not like enormous cost, but it's still a wasteful cost, is that the distance field shadows here was enabled. And what we're doing, or what we have, is virtual shadow maps, right? We have that available. We can also just show that off here on the virtual shadow map, and let's say like the cache pages or something like this. So we can see that here we have them. We can see that they're invalidating as we go through the world. So that's all working. However, it's for some reason it's using distance field shadows. Now we don't really need that. Also, if you were to use distance field shadowing and you have virtual shadow mapping, then maybe it's used for super far into the distance, which I think is probably also where they're using it. We have here the light mixer, which should be under window light mixer, where we have all of our lights. And here we have the blendable atmosphere far west. Well, actually, I should unlock this thing right here, because otherwise I still have that whole thing selected. And that's where we have a directional light. And then we should be able to find somewhere. Maybe I can just better search for distance field shadows. So it is enabled. And there's some kind of distance field shadow distance. This is probably enabled because on the lower end, they are not using virtual shadow maps. And I think that's only purely for DirectX 11. However, the engine is not really clever about disabling stuff. So distance field shadows could still be rendered and kind of used, even if you're not really seeing the difference. And especially because you're already using something like virtual shadow maps, which can have like large distance, large scale shadows at very large distances. And distance field shadows was really a trick before that, when we had cascaded shadow maps, which of course still exist. You can still use those, where they could cheaply render distance shadows and then use a cascaded shadow map textures at a closer distance, right? But this is still on, and actually it doesn't add just cost here in the projection. It's also somewhere else. I think there was somewhere else in the single layer water. Towards the end, they also have this begin ray tracing distance field shadows. Now on single layer water, which is actually incurring a cost, like even now, even when we're not actually looking at water, because the water is just here. But even if it's like occluded by auto geometry, you're not seeing it whatsoever, you're still paying a cost. And I can actually just check that out right here. If you can just see it. Oh yeah, there we actually go. Single layer water. It's right here. 0.3 milliseconds. And well, now it's of course more, because now we're seeing it in full view, 1.2. You always pay a little bit of cost if it doesn't get properly culled. Right? And what usually happens is that you have these large, massive shapes, right? If you just go stat non again, it's basically 1 mega plane. And that's very convenient, but you know, there's a bit of a trade-off there to be made, where it can never cull because the bounds are just the entire map. So you'll always be rendering at least some of the cost for single layer water. Now I have a few more things I want to say about single layer water, and then we're done here. So then you can just head out checking out some of the other optimization lessons that I have available in the game optimization course, or you can check out the written companion guide doc that we'll be making that lists some of the console variables that we're using, some of the tools, and lists some other resources and tweakables for the things that we've discussed today. And hopefully I can make a bunch more of these videos covering specifically Far Far West and just slowly getting to have this run really well on an RTX 3060. I think it'll be really fun to sort of explore and actually optimize these things together in these kind of lessons. Now I have a few more things I want to say about single layer water, and then we're done here. Besides it just always incurring a cost, one thing that I also notice is if I'm just going to go to the single layer water so you actually see it here, is that there's a few things we can tune. And one of the things that I have actually disabled, which you should also certainly consider disabling, is r.water.singlelayer.depth prepass. And if we actually go into the engine source for a change and search for the command, what we can see is that if we just search for that, and this is often how I find my things as well. Like I often just search for console variables in the engine source because you'll find a lot of interesting comments. You'll find a lot of interesting other console variables that might be placed right next to it. And that way I really just have this giant node stack of console variables to try out and different little tidbits that I learned just from looking at the engine source without even having to really understand the code all the time. Currently, VSM is the only feature dependent on the depth prepass. And the thing that they're doing is that as soon as virtual shadow mapping might be available, it's not even checking whether or not it's enabled. If it's just supported, then they are enabling the depth prepass. Now, I don't think we do have virtual shadow mapping, but I don't think we're really going to miss out on having this disabled. I don't really care so much about super accurate shadows on the single layer water, which it might be doing. I don't think we need in this game, at least, right? Your game might be different, but in this game, we might not need shadows rendered accurately in or on the water. And so what I just did is disable that. And the thing is that actually going to cost the cost. Of course, here it's already disabled, so you don't see it. But I think it caught the cost by about 0.3 milliseconds just from not having that thing, which was just enabled just to be safe. And you'll find that this happens a lot with a lot of engine features. It's just enabled just to be easy to use, not to be fast. Keep that in mind with just a ton of things. Also, a lot of things like volumetric fog are going to be tuned to be sort of like universally looking good, but it's probably overkill for your game. So, I'm just looking at volumetric fog right here, which is also another thing that we should really be tuning as much as possible to be just as cheap as possible without losing any of its detail or without like being super noisy and artifacty, right? We really want to figure out just being on just on the edge of that. Again, of that, I also have a lesson in which I tune it a little bit in another game called The Forever Winter. So go check that out in the game optimization course. However, I was still here in the single layer water. Now it's taking, in this case, it took 1.2 milliseconds. We were probably at that point looking at it, right? Let me just double click, get rid of the vis buffer and the decals and shift to scroll. So we can see that it does go a little bit all over the place. Sometimes it's 1.3 and here it's 0.3. So here we probably were not looking at the water, but we still incur that cost regardless because it's in the scene, it's in the view. It hasn't been properly culled. Only when the bounds are actually off screen would it be possible to just skip the render pass entirely. So what we can do for the single layer water is if you do want distance field shadows, but not on a single layer water, you do have a command for that. Another one, r.water.singlelayer.distance field shadow, which you can disable. And also it's marked as scalability. So you might choose to have it available in certain scalabilities, but not in others. I'm not even sure if it's going to be like a meaningful shadowing effect. I think in this game, which is pretty stylized, actually, I don't think we're really going to need it. And this is what I mean as well by discovering interesting things. Like I was just searching for this console variable right here. And then what I see next to it is whether or not we are going to compile support in the materials. So this would be interesting because not only do we, if we disable this, which we should if we have just this disabled as a project-wide setting, if that's the case, we don't change it based on scalability, then we might as well just disable this too, which means that the shaders are not going to be compiled. And that has two benefits. Well, first of all, we don't have to bother spending the time to compile that ever in our project. But more importantly, it's going to be fewer shaders that exist in your cooked game, and also fewer possible shader permutations, which would have to be compiled when your game launches with DirectX 12, right? So this will be worthwhile to take note of. And of course, when you're here, you should really just check out all of these other r.water.singlelayer commands, because there's a lot of very interesting ones. Another one that I think you really should tune, and that we have also set here in this particular project, is the r.water.singlelayer.reflection. We can just search for that one. And in the default scalability, we've set it up to be, at the moment it's very barren, because most of this is actually done through Blueprint, because it's basically a full Blueprint game. It's using almost no C++. And it's running really well for a Blueprint game, I will say. We can look into that in another video as well, like how the Blueprint is working, and how that could possibly be optimized further, but also like some of the optimizations that have already applied, because they're quite interesting. But here we can see that we have reflections, and then on the scalability we either set it to like 0, which would disable it entirely. This might look a little bit off, but it is much cheaper than having it be like reflection mode 2 or 3, which we can see if I just once again search for that. Here we can see like 1 is enabled, and then number 2 would force reflection captures, which is very cheap. If you have proper reflection capture set up in your scene, it would work. And otherwise it forces the screen space reflections. And otherwise, and with 1, which is the default, it would just sort of use whatever is set globally. So that's something that you can mess with, and also something that I'm still going to be messed with a little bit to see what would work best for this particular project. Because also on lower end, probably or maybe the best thing to do is just not use single layer water at all, and rely on some simpler water material that maybe not look as beautiful and not have the same like great effects, but would also just be generally cheaper to run for the low spec. Especially if you want to also run this again on integrated GPUs with DirectX 11 and super limited resources. I don't think we're really going to be able to spend the resources on single layer water. And so we got a little bit sidetracked by just talking about the distance field shadowing on just the water. But I think in this case, what we really be looking for is the r.distance field shadowing, and disable that entirely, well, all of our scalability levels, unless we are maybe using DirectX 11. We would just have to override this in the project, check like, are we running DirectX 11? Then we're probably going to be using non-virtual shadow mapping. So then enable distance field shadowing. Otherwise, we just turn it off. And so that would be a bit of a free optimization, at least for everything that is DirectX 12 with VSM, because now just rendering it and taking up a bunch of time here in the unbatched light projection without really contributing anything to the scene whatsoever. Now, this video already got probably super long. I don't even know how long this will end up being. I think there's a lot more to talk about. I think what I'll do on my end is actually properly apply these optimizations offline, and also fix more of that mask material, because really that's a performance killer on nanite, unfortunately. We could also still consider maybe non-nanite foliage. It's performing so poorly during nanite, and if we don't have the capacity to change them to be fully rendered meshes with opaque materials, maybe that's an option. We'll have to do a bit of a comparison there. But I think for a lot of them, we can actually get away with having better cutouts of the meshes, so that a lot of them can just always be opaque. And then maybe some of them can have that toggling of the pixel programmable distance. I think we have like a ton more to talk about. Maybe in the next lesson, we can do actually one where combat is happening, because then we get so much more variety with a ton of like particle systems spawning or being culled, hopefully. A lot of translucency happening from all of those particles. We have a lot of skeletal meshes being rendered. Then we have just a ton of happening, right? Today we were just looking at basically a static scene, but that's something that should already be super performant before we even bother with the combat. This is, I think, a good start in order to get this to run well on a RTX 3060. Optimization is just a really long process. You really have to understand your content really well. So we have a lot more to do. And I'm very excited, at least, to continue digging into this. And also with some more targeted videos. I want to focus on like taking a few very specific examples that are probably also happening in your game with things like Niagara pooling, how they might be not pooling as you expect, or like what you could do to improve your spawn cost of things like your projectiles and all of these things that are happening during combat, because that's also really one area where you often have like large spikes that are very interesting to solve. And be sure to check out all the resources that I'll link in the description of these videos, where I'll also have some more in-depth information about some of the things that we covered today, so that you can dig into this yourself with your own projects and see where you can find out more. So I'll see you in the next lesson in the game optimization course.